Hey guys, it's Miss Johnson here, and I'm here to bring us our first video for Chapter 8, talking about multiplying and dividing rational expressions today. Our example up at the top says the Goody Shop sells candies and nuts by the pound. One item is a mixture made of 8 pounds of peanuts and 5 pounds of cashews. Therefore, 8 out of 8 plus 5, or in other words, 8 out of 13 of the mixture is peanuts, or 8/13 of the mixture is peanuts. If the store manager adds an additional X pounds of peanuts to the mixture, write a new ratio to show what the portion of the mix, which portion of the mix is peanuts. So what's happening here is this is what we're currently starting with, and to that we're adding X pounds of peanuts to the mixture. So we start with 8 pounds of peanuts, now we're adding X to that. But that doesn't just add X to the numerator, it doesn't just add to the peanuts, it also adds to the total. So I have to put that X on the bottom as well. These are the types of rational expressions that we're going to be looking at all throughout Chapter 8. Rational expressions, ratio, tells you we have a fraction bar in there, numerator over denominator, and we're going to have some variable terms in there, definitely. And that's exactly what a rational expression is. A rational expression is a ratio of two polynomial expressions. A ratio of two polynomial expressions. And that's just an example there, x squared plus 5x minus 2 all over 3x plus 1. It's a ratio, it is a polynomial on the top and a polynomial on the bottom. For multiplying rational expressions, we want to multiply the numerators and multiply the denominators. So we would multiply the tops, multiply the bottoms. And this, if you'll think back to when we talked, or when you learned how to work with fractions, this is the same as fractions, because that's kind of what we're working with here. Rational expressions are basically fractions that have variable terms in them. Dividing rational expressions means that I need to multiply by the reciprocal of the divisor. This is, again, the same as fractions. And what happens when we divide these things is we're going to keep the first one, change multiplication to division, or change division to multiplication, and then flip the second one. Okay. So here's some steps for us to think about when we're thinking of working with these rational expressions. When we are simplifying this, we need to factor. There's going to be a lot of factoring in Chapter 8, and that's what we just talked about with our factoring review yesterday. We're going to factor everything that we can. We can simplify things that cancel out. For example, when I have 3 divided by 3, that's 1. So I could cancel a 3 over 3. And there's going to be a lot of canceling that we can do. Perform whatever operation we're doing. Sometimes it's multiplication, division, that's what we're talking about today. Tomorrow we'll talk about adding and subtracting. And then you always have to check again to see if there's any more factoring or simplifying that we can do. Because sometimes after you do the operation, there's more simplifying left over. So let's do some examples. I'm just going to start with monomials. Keep it kind of basic at the beginning. I have 4a over 5b times 15b squared over 16a to the third. So now if we think back to Chapter 6 when we looked at polynomials and our properties of exponents, I'm going to just go through and see if there's things that I can cancel out of the top and the bottom. There's no factoring to do here because I don't have any polynomials. They're all just one term together. But I can cancel some factors. For example, I know that 4 and 16 have a common factor of 4, so I'm going to divide that out. 4 divided by 4 is 1, 16 divided by 4 is 4. I know that 5 and 15 have a common factor of 5. That would be 1, that would be 3. Same thing with the variables. I can cancel those as well. I have a over a to the third. That means one of my a's is going to cancel out, and I'm going to be left with 2 on the bottom. Because I started with 3, I'm canceling 1. B's, I'm canceling 1b off the bottom, 1b off the top, which makes it just b to the first power. Now put together what you have left. On the top, I have 1 times 3b, which is 3b. On the bottom, I have 1 times 4a squared, which is 4a squared. So that is my simplified expression there. There's nothing else I can do to reduce that. 3/4 is already reduced, and that's my answer. Let's take a look at number 2. In number 2, now we have 4x squared y over 15a to the third b to the third divided by 2xy squared over 5ab to the third. So take a look for a second. Now, there's this big stop sign here to remind you to look at what you're doing. You are dividing. So the first thing that I need to do is I need to flip that second fraction upside down, that second ratio. So I have 4x squared times y, 15a to the third, b to the third. That stays the same. I don't touch it. That's just as it is. I'm going to change my multiplication or my division into multiplication, and then I'm going to take the reciprocal of the whole second fraction. So I have 5ab to the third on top now and 2xy to the second on the bottom. Now I'm back to my steps for multiplying. See if there's any factoring. There isn't here because these are all monomials. And then I'm going to look for factors that cancel out. So for example, I have 15 and 5. I can get rid of that and make that a 3. 4 and 2, that's going to be a 2 and that's going to be a 1. My variables, I have 2 x's on top and 1 on the bottom. So this goes away and I'm left with x to the first. The y's, I have 1 y on top and 2 on the bottom, so this is going to go away and I'm left with y to the first. Then I can look at the a's and the b's as well. I have 1a on top, 3 on the bottom, so I'm going to get rid of that 1 and that's going to leave me with 2. And then b to the third over b to the third, both of those are going to go away. So my b's are all gone. Now, take a look at what you have left. It's really important that you write really neat on questions like this because there's going to be a lot of crossing out, a lot of Xing out. It's going to be hard to see things that are left over. So if I try to find what's left over, I've got a 2, I've got an X, and I canceled everything over there, so I just have 2X on top. On the bottom, I have a 3, I have an a squared, and I have a y. 3a squared y. And then I also check, is there anything else I can do? No, there's not. There's no variables. We should only see each variable written one time. That's one way that you know you've simplified it. When you have monomials, each variable should only be there once, and your number part should be reduced as much as possible, and 2/3 is. Let's try a couple more. Number 3, I'm back to multiplying. I have 8m squared n over 5r squared times 15nr over 12m to the third n to the second. Now, so far we've been looking at things that only cancel from like the left fraction and the right fraction, but really it doesn't matter which side of the left and the right they're on. As long as you have a factor on the top and a factor on the bottom, you can get rid of those. So for example, you've got an n here, that's going to cancel one of the n's on the bottom. So even though they're on the same side, you can still cancel them out. If I go back and look at the numbers, let's take a look at the numbers. 8 and 12 have a common factor of 4. That's going to be 2. That's going to be 3. 5 and 15 have a common factor of 5. That's going to go away and be a 1. That's going to be a 3. And then if you look again, you now have created a 3 over 3. 3 over 3 can also go away. The m's, m squared over m to the third, I can get rid of all of the ones on the top, and I'm going to cancel 2 of the 3 on the bottom, which just leaves me with 1. I already canceled one of those n's, and I'm going to get rid of this other one as well. So now my n's are gone, taken care of. And then r over r squared, I can get rid of 1. It leaves me with r to the first. So now I've canceled out a lot of stuff here. Let's see if we can figure out what's left over. I have a 2 on the top. I've gotten rid of everything else on the top. On the bottom I have an r and I have an m, and I've gotten rid of everything else. So 2 divided by rm. You could also write that as 2 divided by mr, which is technically probably how you'd see it on a multiple choice test, because typically we write our variables in alphabetical order, but either one is correct, doesn't matter. They both work. Okay, let's do another example together and take a look at number 4. Now I'm back to 18ab squared divided by 25x squared y to the third, and that's all divided by 9b over 10xy. So again, now I'm doing division. So before I can do anything, before you do any simplifying, any factoring, anything, I need to flip that second ratio. So I have 18ab squared over 25x squared y to the third times 10xy over 9b. Now I can go to work and simplify. So I'm going to look for the numbers first. 18 and 9 have a common factor of 9. That's going to be a 2. That's going to go away. 10 and 25 have a common factor of 5. That's going to be a 5. That's going to be a 2. I have one b that I can get rid of. That's going to go away, and that leaves me with b to the first power. I have one x that I can get rid of. That's going to go away and leave me with x to the first. And I have one y, which is going to leave me with y to the second on the bottom. Okay, I have a little bit more left over here than I had in the last question. I have a 2 times a 2. That gives me 4. I also have the a and the b, so 4ab on top. On the bottom, I have a 5, I have an x, and I have a y to the second power, so 5xy squared. Nothing else to reduce, no more variables to cancel out. That's my answer. All right, I'm going to go ahead and stop our video here for today. Don't forget to go back to Schoology and take your Schoology quiz. Thanks for watching, and we'll see you tomorrow.